Yeah, hi everyone, welcome to my channel. So for this video, let's see about Tanh activation function. This is right after we discussed about sigma activation function. So okay, let's see what are the advantages and what are the disadvantages that we're gonna face for Tanh activation function. And okay, so this is the formula. This is the formula for Tanh activation function. Yes, and this is the range of the derivative. Yes, um, it is differentiable. So let's see the like what is the range of tan h activation function. So tan h activation function ranges from 0 to 2, sorry, not 0, ranges from 1 to -1. So this is actually the tan h activation function, and as you can see, it is zero centered as it is passing through zeros, right? So it is zero centered, and yes, it is quite similar to sigmoid function that we have already seen. It is but it is zero centered as it is passing through zero. And for large positive, infinite positive, it will give you uh, one, like it will be constant here. And for large negative value, so this seems to be constant here, suppose -1. Okay, so let's see the advantages. Okay, so it is zero centric, as you know, I have already discussed in sigma activation function. Zero centric actually basically help you to do faster optimization of weight, and the convergence will be good. Okay, in gradient descent, and you get the direction positive and negative of the gradient. Here actually, as it ranges from plus positive to -1 negative, so it is giving you the positive value and negative value in the gradient descent, so that we can suppose this is a gradient descent curve, and here actually we are getting, if we draw tangent here and this value is giving you the um, very much positive, so you need to little bit go this direction to find the global minima. So we need to what, reduce the weight, so it is a negative, sorry, it is a highly positive tangent, so we need to little bit go in the backward direction, little bit you have to reduce the weight in order to go near to the global minima. If suppose it is a highly negative tangent, so we need to do what, you need to just increase the weight to go to the global minimum. So this direction actually helps us to converge your converge your weight to the global minimum. Yes, the finding derivative is smooth. Yes, derivative is easy to find here in tanh, and yes, it is slightly better than a sigmoid function, as the optimization is better. The I have showed you how the optimization is better by giving the direction and geocentric. Yes, it is better than the sigmoid, like slightly better than the sigmoid, because it helps us doing the weight optimization in gradient descent. Okay, so this is all about advantage. Let's discuss about what is the issue, what is the disadvantage of tannage. Yes, tannage also have vanishing gradient problem. Yes, it is also have the vanishing gradient problem, as this is same type of what, same type of graph or plot is being drawn as sigmoid function. So I'll discuss about how like it is performing vanishing gradient depend. So it is also computationally expensive, as you can see, that there is lot of exponential what to say, loss of exponential function needs to be find out. So yes, it is quite computationally heavy, so it will take time to calculate your calculate or your formula during forward and backward propagation. Yes, it is computationally little bit expensive. Yes. Okay, so let's discuss the vanishing gradient, like how it is doing vanishing gradient in both sigmoid function and tanh as well. Suppose if we are going to consider this particular curve or this particular function graph for tanh. So uh, if you are going to do if your x is very much negative or very much positive, like if a larger value of x, actually if you are going to, if your value is nearer to 0, okay, then you can find out the tangent. Okay, so it will pass through someone line, so you can find out the tangent here. And yes, the positive also, if it is little bit positive also, you can find out the positive. um, Here, find out the positive in the sense, here actually we can draw the tangent line, and this tangent, actually in this particular tangent we can find out the derivative, or you can say the gradient. Gradient is nothing but the derivative of loss with respect to derivative of uh, weight, right? This is the gradient that we need to find out. So this is the gradient I'm talking about. So yes, we can find out the gradient here. But if your value is quite a high positive number, so in this type of position you cannot find out the tangent, because your tangent line will be parallel to your function graph. So in highly negative also you cannot find out tangent here, because your if you draw the tangent here, so it will be quite parallel. So there will be no gradient. There is, like, if you change the weight, if you change the parameter, change the weight, there will be no change in loss. So it will be quite parallel. So the gradient will be 0, or you can say there is no gradient, right? So if it is gonna be, the gradient is gonna be 0, so in weight optimization formula, this is the new weight, this is the new weight, right? This is new weight that we are going to update with the old weight, minus some learning rate, and the gradient, right? The gradient means this uh, a loss with respect to it. So if this gradient becomes 0, if this gradient becomes 0, so this whole part will become 0. If this whole part will become 0, then the previous weight and the current weight will be same. So there is no like there is no weight optimization happens. So this is how actually vanishing gradient problem occurs, and this actually um, a major disadvantage. Actually in further activation function we are actually uh, overcoming this advantage, vanishing gradient problem, like relu Ricky relu. So let's see, for next video I'll discuss about remaining activation function. So this is all about tanh activation function. So if you have any doubt, so comment me out, I will try to help you guys. Thanks.